My name is Jillian Silvertand, and I'm with the Geodatabase development team here in Redlands, California. Joining me today is Craig Gilgrass, also with the Geodatabase team in Redlands. We would like to welcome you to today's live training seminar, What's New in the Geodatabase at ArcGIS 9.2. To begin, I would like to briefly go over the topics that will be covered in today's session. I will start by exploring how 9.2 has made using the Geodatabase a more simplified and easier user experience by adding new data sources, bundled database servers, and implementing the new high-precision coordinate storage. Secondly, I will cover some of the enhancements made to the editing environment for data stored in an ArcSDE geodatabase. Lastly, I will provide an overview of the new geodatabase archiving and replication functionality available at 9.2. Throughout each topic, there will be software demonstrations, and at the end of each topic, there will be time for review and Q&A. During development, the Geodatabase team has strived to keep these goals in focus. Foremost was the goal to simplify using the Geodatabase and to continue to improve quality and performance. Many of the enhancements that we will discuss today were in the aim to simplify the user's experience from performing tasks such as creating data, using ArcSDE technology, editing data, and administrating the geodatabase. Additionally, users wanted more storage options for the geodatabase, which will be introduced at 9.2. The geodatabase is a native structure for ArcGIS. Geodatabases work across a range of database management systems and file systems, come in many sizes, and support a varying number of users. They can scale from small single-user databases built on files up to larger workgroup, department, and enterprise geodatabases accessed by many users. Personal Geodatabase for Microsoft Access has been available since ArcGIS 8.0 and continues to be available in 9.2. The File Geodatabase is a new storage option and utilizes a directory of binary files to store the data. This type of geodatabase is not tied to a DBMS. Personal and workgroup geodatabases are part of the new bundled database server option available with 9.2. These types of geodatabases use SQL Server Express Edition to store the data. Enterprise geodatabases have been available for many years and support 4 DBMSs. These last 3 types of geodatabase utilize ArcSDE technology for storing, connecting, and editing the data. The File Geodatabase is new at 9.2 and provides a very high-performing file storage option for the geodatabase. This storage model offers users the ability to virtually store unlimited amounts of data. Additionally, the File Geodatabase has options to compress the vector data and is supported on Windows and Unix platforms. The full geodatabase model is supported, and it can be created with the ArcView, ArcEditor, and ArcInfo licenses. When deciding on which geodatabase storage model you need to use, you must compare the differences between the personal geodatabase using Access, the File Geodatabase, and ArcSDE geodatabases. First, let's look at the storage capacity of the different types. The personal geodatabase for Access has a limit of 2 gigs per geodatabase. The File Geodatabase, as I mentioned previously, is virtually unlimited, as by default you can store up to 1 terabyte per table, and this can be extended if necessary. ArcSDE geodatabase storage is dependent on your server and hardware choices. The personal geodatabase for Access is only supported on Windows, while File Geodatabases and ArcSDE geodatabases can be supported on Windows and Unix. Geodatabases implemented with ArcSDE technology will support versioned editing, replication, and archiving. I will talk about versioned editing in the next topic. In this first demo, I want to show you how easy it is to create and use a file geodatabase. So I'm going to open up ArcCatalog and first navigate to a directory. I will create my new file geodatabase by simply right-clicking, clicking on New, and saying File Geodatabase. So a new file geodatabase is created, and just like a personal geodatabase for Access, I can rename this. I'm just going to call it Seminar. Now, just like any other geodatabase, I can quickly load data into this geodatabase by using another source. So I'm simply going to copy and paste my fire stations into my new file geodatabase. So now I have a new feature class called Fire Stations, and just like any feature class, I can preview this data, I can change its properties, I can edit it, etc. We can see that the creation and use of file geodatabase is very similar to the personal access geodatabase. In addition, it has all of the advantages that I mentioned earlier, such as the size, performance, and support on Windows and Unix. As I mentioned previously, new at 9.2 are bundled database servers, which we call personal and workgroup geodatabases. This storage option was created to offer users an inexpensive option for storing data in a DBMS utilizing ArcSDE technology. These geodatabases will be very useful for smaller organizations that do not have a need to purchase a large RDBMS. For example, a small consulting firm may want to perform version editing or replication, but have no need to purchase an RDBMS. Additionally, these geodatabases have an administration interface with an ARC catalog and can provide an easy testing environment. Personal and workgroup geodatabases are very easy to install and deploy as they use preset configuration settings during the install and Windows authentication for user connections. As the administrator of a personal or workgroup geodatabase, you can perform all your geodatabase and server administration through ARC Catalog. For example, you could add or remove users, stop and start the server, create new geodatabases, and back up your geodatabase, all through ARC Catalog. This simplified user experience will allow smaller organizations to take advantage of ArcSDE functionality without needing to administer a database server using DBMS tools. If you have decided to implement an ArcSDE geodatabase, next you must decide which type. First, examine the supported RDBMSs for each type. Personal and Workgroup only support SQL Server 2005 Express. For this reason, Personal and Workgroup are supported on Windows. Enterprise geodatabases support 4 different databases: IBM DB2, IBM Informix, Microsoft SQL Server, and Oracle, and will support multiple platforms. Personal and workgroup geodatabases have a storage limit of 4 GB per geodatabase. This limit is dictated by SQL Server Express. Additionally, SQL Server Express will only take advantage of 1 CPU and 1 GB of RAM. In comparison, if you need to store larger amounts of data in your ArcSDE geodatabase, you can use the enterprise version, which is only limited by your hardware. In terms of licensing, personal geodatabases require either an ArcEditor or an ArcInfo license. Workgroup will need the ArcEditor ArcInfo license plus the workgroup level of ArcGIS Server. Enterprise requires the enterprise level of ArcGIS Server plus your regular DBMS licenses. So in this next demo, I want to show creating a new workgroup geodatabase. The new personal and workgroup geodatabase make implementing ArcSDE technology very easy in your organization. So using ARC Catalog, I can easily and quickly create a new personal or workgroup geodatabase. So to create that, I'm simply going to navigate to my database server connection, right-click, and click New Geodatabase. I'm going to name this geodatabase Montgomery. And I'm simply going to give it an initial size of 25 megs. When I click OK, ArcGIS is building a new geodatabase within SQL Server and populating this database with the required geodatabase and ArcSDE tables. I created the geodatabase with an initial size of 25 megs because that's sufficient to hold the data I'm going to load into it. However, as more data is added over time, this workgroup geodatabase can increase in size to accommodate that new data. So now that my new Montgomery workgroup geodatabase is created, I currently have no features in it. And I'm simply going to copy and paste some of my data into my new Montgomery database. So I'm quickly copying in these feature classes that are part of a feature data set into my Montgomery workgroup geodatabase. So as we can see, creating my workgroup geodatabase was pretty straightforward. And now I have data, a feature data set, and I can preview and use this data. Additionally, because this is a geodatabase that's implemented with ArcSDE technology, I can perform version editing. So I can very easily right-click and version my data. So within the space of a minute or so, I've created a new workgroup geodatabase that supports versioning, and I've already copied data into it. Additionally, I can easily manage this geodatabase through ArcCatalog by performing administration tasks such as backup or permissions, etc. So all of your administration tasks are right through ArcCatalog. Great. So the next topic we're going to talk about is the new high-precision storage at 9.2. In prior versions of the geodatabase, it was important when creating new feature classes that users specified the spatial extent and coordinate resolution of the class. This was often not a straightforward process, and if the data required a very high coordinate resolution and had a large spatial extent, users would frequently receive out-of-bounds errors. At 9.2, the new high-precision data storage solves this problem by choosing smart defaults for these parameters, making creating a feature class as easy as creating a shapefile. So the new high-precision storage really simplifies the user experience when creating a new feature class. To create the new feature class with 9.2, all you must specify now is the coordinate reference system being used, e.g. UTM zone 11, and the tolerance of the data. The tolerance simply specifies the minimum distance between coordinates before they are considered equal. The geodatabase will then provide smart defaults for the spatial extent and for the resolution. The default resolution will be 1/10 of 1 millimeter in the data storage unit. Should you need a higher resolution, you can choose to override the defaults. However, for most data, the defaults will provide ample resolution. So I'm going to demonstrate just how easy it is to create a new feature class with our new high-precision data storage. And I'm going to use our new file geodatabase that we just created. So I simply right-click on my new file geodatabase. I'm going to click New Feature Class. For my feature class name, I'm going to call it Townships. And notice that assigning the geometry type now is a simple drop-down list on the first panel. I'm going to choose a polygon feature class. Additionally, we can set the Z and M values on this first panel as well. My data doesn't require Z and M, so I'm just going to leave those unchecked. On the next panel, I need to specify my coordinate system. I'm going to choose a NAD83 UTM coordinate system, and this is going to set my data storage units into meters. On the next panel, I specify my tolerance for this feature class. By default, the tolerance is based on the resolution used for the data. The default resolution is 1/10 of a millimeter, and the tolerance is 10 times that, or 1 millimeter. Should you need to specify a higher resolution, you can do so by unchecking the defaults. However, for most data sets, 1/10 of a millimeter resolution is a good value, and that's what I'm going to leave mine as. Next, I can specify the configuration keyword to define storage properties for my data. At this point, I'll just accept the defaults. I can then add a field. So I'm going to add the name field, and it's a text field. Before I click Finish, I want to point out one more thing. The shape field has a spatial index assigned to it. A spatial index is very important when querying the data based on the spatial location. Notice that for new feature classes, a grid size of 0 is assigned, indicating the spatial grid index will be built at a later point. This is really nice because, as we're going to see later, this is going to get calculated for us. So I'm going to click Finish, and now I'm simply going to load some data. I'm going to load my township boundaries, and that's quickly going to insert that data. So I can preview it, and I see I have a couple of features. Now I'm going to right-click and go to Properties. On the General tab, notice I have High Precision Data Storage. And on the Indexes tab, notice my grid size has been calculated for me. So at 9.2, ArcGIS automatically rebuilds a spatial index at the end of certain operations, such as at the end of a data load into an empty feature class. You can optionally choose to recalculate the index at any time. These improvements into the user interface have greatly enhanced the user experience when creating feature classes and maintaining the spatial grid index. So just to quickly review, the file geodatabase offers many advantages, including the storage size and performance. The new personal and workgroup geodatabases offer a very easy way to implement ArcSDE functionality, and high-precision storage will make creating feature classes very easy. So now I'm going to turn it over to Craig to answer some of your questions that have come in.
Thanks, Jill. Let's take a look at some of the questions we got coming in from you, people watching here today. First, Vicky from Arlington, will my old personal geodatabases or ArcSDE geodatabases even still work with 9.2? The answer is yes. Geodatabases, whether they be personal or ArcSDE, created with previous versions of ArcGIS, will be supported, and you'll still be able to use them within 9.2 in much the way you've been able to do through previous releases. If you'd like to take advantage of the new functionality available in 9.2, you will need to upgrade those geodatabases to the latest release. Mike from Athens asks, how can I tell the difference between a file geodatabase and an access or personal geodatabase in the catalog tree? Two ways to do that, Mike. You can click on the properties of the geodatabase. It's listed on the properties dialog on the front tab. Likewise, you can also enable file extensions to be able to see the difference between the two. File geodatabases have a .gdb extension. Personal access geodatabases have a .mdb extension. Elena from Anchorage asks, will previous versions of ArcGIS recognize the file geodatabase? No, only ArcGIS 9.2 will be able to recognize, create, and use file geodatabases. Pete from Denver asks about file geodatabases. How much faster will they be than personal geodatabases? Pete, it really depends on the type of data and the actions that you're using on the file geodatabase. What we've been seeing from our testing, though, is that in all circumstances, the file geodatabase outperforms a personal geodatabase and also shapefiles. So you can expect better performance for things like editing, drawing, querying when using the file geodatabase. Holly from Mercer Island asks about workgroup and personal geodatabases. Will the size of the database increase as I load more data into it? Yes, it will. You notice that Jill picked a predefined limit to the size of her geodatabase. I think she said it's about 25 megabytes. As she loads more data into that database, the SQL Server file behind the scenes will increase to take that extra data that's loaded into it. Let's see, Philip from Ottawa asks, will Oracle Express be supported or other lightweight DBMSs be supported in addition to SQL Express by ArcGIS 9.2? Not in 9.2. Personal and Workgroup are supported mainly on SQL Server Express, but we are looking at some of these other Express versions that have been put out by database vendors to possibly support in the future. Jill?
Great. Thanks, Craig. All right. So we're going to continue on now and look at our second topic. And our second topic is dealing with enhancements to the editing options for ArcSDE geodatabases. Before we start talking about the new functionality for our editing environment, we need to understand the current editing environment, the versioned editing environment. Versioned editing has been available since 8.0 and offers organizations a method for tracking and presenting the change that has occurred to the data. Changes are accessed through a version, and the edits to a class are stored in delta tables. For example, on the slide, you see we have three versions. We have the default version, we have Craig's version, and we have my version. In each version, the parcels feature class is visible. However, in each version, the edits that we see are slightly different. So in Craig's version over here, we see that he's merged two of the parcels together. In my version, I see those original two parcels, but I see an attribute change on a different parcel. These versions can exist for as long as required, and when appropriate, I can merge, which is also called a reconcile and post, these versions together. The process of reconciling versions will detect conflicts and offer the opportunity to resolve those conflicts. There are many advantages to versioned editing, including the ability to isolate an editor's work over an extended period of time. For example, if Craig is working on a subdivision that has not been improved, this version should not be available to the entire organization until such time that it has been approved. Therefore, his edits can be isolated in his version and no other users will be able to see his work. Versioned editing also does not lock features during editing, allowing multiple users to edit the same data without blocking access. As features are not locked, version editing must provide conflict detection and resolution tools, which are available in ArcMap. Of primary importance when using versioned editing is the need to define the appropriate workflow to meet your business needs. In terms of architecture, very briefly, I wanted to just point out that a feature class is typically made up of several tables, including the business, or also called base table. With versioned editing, changes are then stored in the feature classes A and D table, also called the delta tables, and the changes are accessed through a version. Versioned editing does not easily support non-ESRI client access, as the edits are stored in the A and D tables, not the base table. So most applications are going to read the base table and not understand the contents of the A and D tables. So if we look at the slide, our third-party application is accessing all the data in the base table, and only our ArcGIS applications understand the contents of the A and D table and the version architecture. At 9.2, two new editing options are available for integrating with non-ESRI applications. These options are non-versioned editing and move to base editing. Non-versioned editing is very easy to implement. Any simple feature class or table can be edited in a non-versioned edit session, as long as it has not been registered as version. With non-versioned editing, changes are directly written back to the base table. There are no A and D tables. Therefore, any non-ESRI application and any ArcGIS application can see and edit this data directly on the base table. Additionally, as the edits are written back to the feature classes table using standard DBMS transactions, implementing DBMS behavior, such as a constraint or a trigger, is very easy, allowing the organization to easily integrate their GIS data with other business applications. However, with non-versioned editing, features will be locked during editing, which may cause blocking issues. Also, there is no ability to detect and resolve conflicts, as each edit will simply overwrite a prior edit. Your workflow must adequately account for these considerations. Move to base editing is versioned editing with a twist. All the edits during the edit session are actually stored in the A and D table. However, if you are editing the default version or posting to the default version, these edits will move back to the base table on the save. Therefore, your third-party applications will be able to see those edits as soon as they've been saved to the default version. If your edits are saved to a different version, they will remain in the A and D table and only are accessible through applications that understand the version architecture. So again, this is providing IT integration because our non-ESRI applications can see those edits in the base table, and it's providing that editor isolation and the benefits of versioning because of our A and D tables. So in this next demonstration, I want to demonstrate how to start using a non-version edit session and also demonstrate the correct workflow when using DBMS constraints. So I'm going to open up an ArcMap document, and in this ArcMap document, I have some zip codes. These features are stored in a workgroup geodatabase. Again, to do versioned editing or this move to base editing and non-versioned editing, this is part of our ArcSDE geodatabase technology. So DBMS constraints are going to be very important when integrating your GIS data with non-ESRI applications, and they're used to maintain business rules in the DBMS. So it's important when using the DBMS constraints to follow the correct workflow. So here's my zip codes, and I'm going to need to start an edit session on this. So I simply go to Editor and click Start Editing. And the first thing I see is an error message telling me I can't edit any of the data because it hasn't been registered as versioned. So that means I need to actually do something to start a non-versioned edit session. And that's very easy. I go to my Editor menu and I click Options. On the versioning tab, I uncheck the ability to edit the version, edit the database with the undo and redo. So now I can click OK, and I can actually start editing. So to start a non-version edit session, I have to uncheck this option. When you edit with non-version editing, you are performing standard DBMS transaction editing. In this environment, the transaction spans from the start editing action to the stop editing or the save edit action. All edits within that span are either committed, saved, or rolled back. So now I've started my edit session, and I'm simply going to digitize a new zip code. So I'm not going to turn on any snapping, and I hope you guys forgive me, but I'm just going to make a very quick edit. So I'm making a little polygon. I right-click, and I click Finish Sketch. And again, I have an error. As soon as I finish the sketch, the Geodatabase is attempting to store the feature in the database. However, in this example, I've received an error because I have a DBMS constraint on the zip code attribute to not allow non-unique values or nulls. So by trying to insert a feature without setting the value for this field, I have violated the DBMS constraint. I do not want to violate any DBMS constraints. They're placed there for a reason. They're placed there to comply with business rules. Therefore, I must use the correct workflow. In this example, it's very easy. I need to assign the attribute value before attempting to store the data. And I can do that by clicking on my Options tab, going to the Attributes tab, and checking on Display the Attributes dialog before storing the new features. So now I'm going to digitize that feature, and the Attributes dialog opens. I can set my zip code and the features stored. Now, of course, I need to either save or end my edit session without saving, and I'm going to choose to simply save those edits, and this change is now committed to the base table in my database. So by enabling non-version editing through ArcGIS, we're offering organizations new ways of integrating their spatial data with other applications. Now, we do have some new editing options, which I just talked about, but we do also have some enhancements to the versioned environment. So next, I want to share with you some of these enhancements. Prior to 9.2, all conflicts were identified by object, and frequently, users would customize this behavior to identify conflicts by attribute. At 9.2, we provide you the option to either detect conflicts by attribute or by object. The default method, which is by object, detects conflicts if this edit was on the same feature regardless of which attribute was changed. This is the same as the conflict detection mechanism at 9.1 and below. For example, if Sam edits the name attribute and Jane edits the geometry of the same feature, a conflict will be detected. The second option, which is by attribute, is now available with 9.2. and is used to detect the conflict only if it was on the same attribute of the same feature. For example, if Sam edits the name attribute and Jane edits the geometry of the same feature, these edits are not in conflict and both edits are preserved. However, if Sam and Jane edited the name attribute, this would be identified as a conflict. Additionally, at 9.2, there have been enhancements in how conflicts are displayed and resolved. The new conflicts dialog allows you to visualize the conflicts in the display area instead of using the map. Additionally, you have more choices for conflict resolution, allowing users finer granularity in determining the correct edit. Also, for ease of navigation, all conflicts that have not been resolved will be displayed in bold in the tree, and once the conflict has been resolved, it will no longer be bold. So let's do a reconcile and take a look at these new changes. So I have two map documents. The first map document is looking at the default version, and we're looking at the parts of the default version. And in this version, I have made a couple of changes, and I've highlighted them on the screen. I've deleted a feature. I've changed the attribute, the name attribute of this park in the lower quadrant. I've called it Lynn Canyon Park. And I've also changed the name of this park to Connaught Park. Excuse me. If I take a look at the child version, I'm looking at, again, a different map document, and I'm looking at a different version. In here, I've digitized a new feature. I have changed the attribute of this lower park to Lighthouse Park, and I've changed the geometry of this middle park and extended the boundary. So now that we have these two versions with two different sets of edits, we want to reconcile the changes together. To start reconciling, I must start an editing session. Then I click the Reconcile button. Notice we have a new Reconcile dialog. We are reconciling against its parent, which is the default version. And I choose to define the conflicts by object or by attribute. I'm going to choose by object first, and then we'll do this again and use by attribute. When I click OK, I receive the message that I have conflicts, and I'm going to click Yes to resolve these conflicts. Notice in the conflicts dialog box, my tree view is bold. So I have two conflicts in my parts feature class, feature number 15 and feature number 65. Clicking on the conflicts display button, I can now visualize the differences. So I click on feature number 15, and I can see that the park name is in conflict and the shape field is in conflict. So let's take a look at the display area. In my current edit version, I can see that the boundary of this feature has changed. In my conflict version, or the default version that I just reconciled against, the boundary is the same, but the name is different. Likewise, I can look at feature number 65. Feature number 65 has a conflict only in the name field. So one of the features in the edit version is called Lighthouse Park, and in the conflict version, it's called Lynn Canyon Park. Let's do this again, but use the other reconcile option. So I'm simply going to stop my edits without saving and perform this again. So now I'm going to reconcile, choose by attribute, and click OK. And yes, I want to review the conflicts. Notice immediately a difference here. We have one conflict being identified, only feature number 65. So what happened to feature number 15, which was in conflict before? Well, feature number 15 was a geometry and attribute conflict. So the conflict or the edit was on two different fields. With this new conflict identification mechanism, it won't identify that as a conflict. It will simply preserve both edits. However, feature number 65 was an edit to the same field, so Lighthouse Park and Lynn Canyon Park, which means I need to resolve this and choose whether Lighthouse Park is the correct name or Lynn Canyon Park is the correct name. Great. Okay, so that's showcased some of the new changes with the reconcile and conflict detection. To quickly review, we know that version editing offers us a lot of advantages, including the isolation of users' work and the conflict and detection. Additionally, with 9.2, we have the new non-versioned editing options, which allows us to integrate easily with our DBMS and IT integration. Now I'm going to turn it over to Craig to answer some questions.
Thanks, Jill. Let's take a look at some of the questions here. Something a couple of you have asked, including Roger from Oron and Simon from Toronto. Do you have undo, redo support with non-version editing? No, as you saw Jill perform during the demo there, she unchecked the ability to have undo, redo in order to start a non-version edit session. If you'd like to undo the edits that you're doing while in a non-version edit session, the way you would do that is to stop editing and not save the edits that you'd made up to that point. Another question from Carolyn in Ottawa. Is there a way to be able to set the filtering of the conflicts to be column by default? You can do that within each edit session. So once you start a new edit session, perform your edits, and you're about to perform the reconcile, by going to the editor options dialog, you can choose to set how you'd like those conflicts to be recognized and handled in the context of that current edit session. Quite a few other examples here, some of them dealing with file GDBs, and we'll talk about some of those. What kind of support for Geodatabase dataset types are available in file Geodatabase? All the Geodatabase functionality that you have available in ArcSDE Geodatabases and personal Geodatabases from the dataset standpoint is available in file Geodatabases. So feature classes, tables, topologies, geometric networks, network datasets, raster datasets, raster catalogs. Those are all available within File Geodatabase. Another question here from David in Chandler. Should I be concerned about file size or disk size when setting whether I want to use high precision or low precision or setting my tolerance? Not really, David, no. You shouldn't let that influence the decision that you're making. The difference that you're going to get is negligible. And what you should really use to determine the resolution and tolerance is, first of all, go with the defaults we've given you. We've tested those over a large number of data sets. They work well, and they're going to work for a large number of users. If you don't think they work for you, then perform some prototyping and see what values work for you. But it should be with respect to what your data is. You shouldn't be so much concerned about how much space it's going to take up on disk. As I mentioned, that's pretty negligible. Another question from Alan and Logan. Do file geodatabases support multi-user access? No, they don't support versioning. They work with a very similar editing model that personal geodatabases stored in Microsoft Access do. Slightly different though. The locking mechanism that we can use on file geodatabases isn't at the geodatabase level, it's actually at the dataset level. So you can have multiple users editing completely different feature datasets within a file geodatabase. So the locking mechanism that you get with personal geodatabases stored in Access being for the entire geodatabase, not the case with file geodatabases. Another question from Janet in Houston, will all geodatabases upgrade? Couple questions we've seen like this. How easy is it to upgrade and so forth? All your geodatabases should upgrade. There's no constraints on that, whether you're using linear referencing or M or Zs or you have geometric networks or topologies contained within it. It's a simple operation. There's an upgrade button on the Geodatabase Properties dialog. Some other questions we got from people such as David in Thunder Bay. What about upgrading to a high-precision spatial reference? How simple is that for data in my pre-9.2 geodatabases? Well, that's an operation you perform on each data set. You right-click on the data set, and there's a command available to upgrade the spatial reference, so it's really a one-click operation. There's also a geoprocessing tool that's been made available for that, so if you need to, you can batch up the operations of upgrading multiple spatial references. A few other questions that we've got here. Am I able to connect to a file geodatabase and say Microsoft Access and edit the attributes in Access? No, you're not able to do that. The file geodatabase is really represented as a folder on disk with a collection of files contained within it. It's not implemented on Microsoft Access like personal geodatabases were. So this kind of leads to a question that I've also seen from a number of users today is, why would I still want to use personal geodatabases stored in Microsoft Access? Well, if you're a user who is editing your data in Access, you go in, you perform Access to do calculations on non-spatial, non-geodatabase type fields, you may want to stay with personal geodatabases stored in Access. It's a completely valid workflow. A number of you have told us in the course of 9.2 that it works for you and you're going to stay with it. So that's an example of where you might want to stay with personal geodatabases stored in Access. Jill?
Great. Thanks, Craig. So we're going to move on and talk about our last topic, which is discussing geodatabase replication and archiving. First thing I want to mention when we talk about these two new functionalities is that this is only available for data that has been registered as versioned, and versioned editing is only supported with our ArcSDE geodatabases, Personal, Workgroup, and Enterprise. In the last section, we did talk about non-versioned editing and move-to-base editing options, again, only available with our ArcSDE geodatabases. These options cannot be used with geodatabase replication and archiving. You must use the full versioned architecture to support these two new functions. So first, let's talk about geodatabase replication. And what this allows us to do is it allows organizations to distribute subsets of data across two or more geodatabases, creating what we call a replica pair with a parent-child geodatabase relationship. Data can be then edited independently in those replica pairs and then synchronized. This is very powerful functionality and should be used appropriately for your workflow. For example, perhaps the federal government is responsible for the census information. However, each province is tasked with performing the updates to the data. Each province can replicate a subset of the data, perhaps based on a spatial constraint, and updates that information. At various times, the changes from the province are then synchronized with the federal geodatabase. The first type of replica we're going to look at is called the checkout check-in replica. This is also called single generation replication. For example, perhaps you have a contractor that is responsible for delivering one set of updates at the end of the project. This data only needs to be synchronized once at the end of the project. So from the parent geodatabase, you check out a subset of the data, and that is now living in your child geodatabase. The child geodatabase can be a personal geodatabase on Access, it can be a file geodatabase, or it can be one of our ArcSDE geodatabases. Once you've checked out that data, you can edit it within that child geodatabase, and then at the correct time, synchronize those changes. So that's also called check-in. The conflicts will be detected upon the check-in. This type of replica only supports one synchronization process. Once the changes from the child have been checked into the parent, that child geodatabase can no longer be used to check in further changes. The next replica type is called one-way replicas, and these are used in situations where changes from the parent geodatabase are sent frequently to the child geodatabase. For example, assume you had a publication geodatabase that was used for all internet and mapping applications. That data is not edited in the publication database. Additionally, you have the production geodatabase where all changes are taking place. Using a one-way replica, you could replicate the data from the production geodatabase to the publication geodatabase and periodically synchronize the changes. So of course, the first thing you have to do is create the replica. So I assign for example, my publication database would be the parent, and the production geodatabase would be the parent, and then I create the replica to the production geodatabase. In this replica type, the child geodatabase must be an ArcSDE geodatabase. Then, when appropriate, once that replica is created, I can synchronize from the parent to the child. You will not be able to send changes from the child to the parent. Synchronization can occur multiple times from that parent to the child geodatabase, as long as the replica has not been deleted, and conflicts are not detected upon synchronization. Two-way replication allows you to transfer changes from the parent to the child and the child to the parent as many times as necessary. This type of geodatabase replication could be very useful if data must be edited in different remote offices and the changes to the data synchronized. For example, say an organization has a head office in New York and regional offices in London, Tokyo, and San Francisco. The head office keeps the master copy of the data, and in each regional office, a subset of the data is edited. Changes can be sent from the regional office to the head office and vice versa. First, you establish the parent geodatabase and create the replica of a subset of the data to the child geodatabase. This child geodatabase must be an ArcSDE geodatabase. Once created, the changes that occur in the child geodatabase can be synchronized to the parent, and the changes from the parent geodatabase can be synchronized to the child. Conflicts will be detected upon synchronization. In this demo, I want to show you the process of synchronizing changes between a field replica and its parent enterprise replica. I'm using a workgroup geodatabase to support this for this example. So here I have my child geodatabase, and I have the parent geodatabase. So assume that these were on separate machines. I can do a very easy synchronization right from ArcCatalog. So in this scenario, a field crew has created a two-way replica from the enterprise data. At the end of the day, the crew is returned to the office and needs to synchronize the changes. To do this synchronization, the field boss can simply perform the action by right-clicking in ArcCatalog, going to Distributed Geodatabases, and clicking Synchronize. However, before we actually do the synchronize, let's take a look at the differences. So I have two math documents that I created to showcase this. So first, I'm looking at my enterprise database. And in this database, I have this gray box indicating what was checked out in the field. Inside this gray box, in the enterprise map, I've digitized 4 new buildings. If I then subsequently go to the field map document, again, I've checked out this data And notice that those buildings are not present because those were performed in the parent geodatabase, not in the child geodatabase. But notice here in the child geodatabase, I have updated the electric lines and the service points. So now I can perform that synchronization. I'm going to do the synchronization through ArcCatalog, but note you can perform the synchronization in ArcMap or with geoprocessing tools if you prefer. So again, I'm going to right-click on my child geodatabase, click Distributed Geodatabases, and Synchronize. Now the first thing we notice here is that ArcGIS has made the synchronization very easy. The tool knows which geodatabase you're synchronizing from. And knowing the geodatabase that you're going from, it knows the replicas you have available. So I have one replica, which I've called Rep Demo. This particular replica has a parent geodatabase, or its relative replica, called parent. So it's filled this in for me. I don't have to do this. The only thing I really need to specify is the synchronization direction. And for this example, I want to go in both directions. So I want to take changes from the child and push them to the parent, and I want to take the changes from the parent and push them to the child. Click Next. The next panel allows you to find how your conflicts will be resolved and detected. These are the same conflict choices that we discussed previously. I'm going to click Finish. Now, while we're synchronizing the changes, what we're doing is transferring the changes from the parent to the child and from the child to the parent and performing the reconcile to look for conflicts. That's completed. So now let's take a look and see what happened. Let's go to our field database. So again, here's our field database, and right now I don't see the buildings. Why? Because I have to refresh the version. So simply on the versioning tab, I click Refresh, and there are my buildings. In the enterprise map, I have all those buildings because that's where they were digitized, but notice the electric lines haven't been updated yet. Again, I simply refresh, and there they are. The changes have been synchronized very easily and very quickly. So now that the replicas have been synchronized, the field crew is ready to go out again tomorrow, make new changes to their field geodatabase, and synchronize those edits. The last thing we're going to talk about today is geodatabase archiving. Geodatabase archiving is new at 9.2 and provides the functionality to archive the changes that have occurred to a feature class or a table in a separate archive class. This functionality can be used to answer questions about how the data has changed over time. Like geodatabase replication, geodatabase archiving is only supported on data that has been registered as versioned. An example of a time-based question could be, what did the feature class look like at a certain point in time? So what did a particular feature or the entire feature class look like? And to answer this question, I must be able to go back and look at the data at that point in time. So what did my data look like on January 1st, 2001? Another example, how has the feature changed over time? So to answer this question, I need to look at all the changes that have occurred to that feature over time. And geodatabase archiving is going to help us answer these questions. So to facilitate answering these questions, all the changes that have been made to that archive-enabled class are stored in a separate archive class. Only the changes that are made to the default version of that class will be archived, and they're going to be archived with a from and to timestamp so that we know when that edit was current. So if we look at the slide, again, we have our typical versioned architecture. We have a base table and an A&D table. When I save my edits to the default version, not only am I saving the edits to the default version, but geodatabase archiving is copying those edits to the archive class. So now the archive class is maintaining a record of all the changes that has occurred over time. So let's look at this in ArcMap. I'm going to bring up a new map document which has my parcel feature class. And in this parcel feature class, I have enabled archiving. So I'm going to showcase answering these common historical questions. The two questions that I will answer are what did the data look like at a particular point in time, and how has a particular feature changed over time? So currently, we're looking at the default transactional version. A transactional version is one in which we can perform edits. To examine the archive information, I must change to the historical version. So to do that, I'm going to right-click on my version, click Change Version, and now in the Change Version dialog, I have the ability to navigate to my historical version, and I click OK. Currently, I'm looking at the default historical marker, and what that default historical marker means is that I'm basically looking at what is current in the database in the default transactional version. So now that I'm looking at my archived information, I'm actually looking at the archive class now, or reading data from the archive class, I can actually change to a different point in time. I can change to a different point in time using a calendar function, or I can change using a historical marker. And a historical marker is really like a bookmark. So I've created some historical markers in my database, and they reference a specific point in time. So the original historical marker was at April 20th at 3:12 p.m. So if I go to look at my original marker, notice the display here. I'm going to change to the original marker, and there it is. That's what the data looked like on April 20th at 3:12 p.m. Now, if I navigate and look at different points in time, I can see how the data has changed. So there's a new subdivision. And then again, we've subdivided the parcel, and again, we've created those parcels. So very easy for us to look back and see how the data has changed over time. So that answers my first question. My second question is, what are the changes that occurred to a particular feature? And to do this, I'm going to add my actual archive class. So I'm looking at the actual archive class, which is maintaining all of the different edits. Using my identify box, I can easily identify on a feature. So notice parcel with the APN number 256120003. This feature has changed 3 times over the course of my editing environment, and I can see those changes. Also, notice the geodatabase from and to date. This tells me when that feature was active. So this representation of the feature was active between 3:12 p.m. and 3:45 p.m. on the same day. It then changed to look like that. So you can see it flashing on the screen. And it was changed one more time. So using geodatabase archiving helps us answer these typical types of questions that may be very important to your organization. So just a quick review. Geodatabase replication allows for organizations to distribute data to multiple geodatabases and synchronize the changes. And geodatabase archiving preserves the changes that have been made to the data in the archive class. All these changes were to archive will include the timestamp. Now I think Craig has some more questions for us.
Thanks, Jill. Caroline from Ottawa again. Can I perform replicas with my personal geodatabase for access or file geodatabases? As Jill mentioned, there's 3 different types of replicas that you can create, or 3 different types of replication scenarios. There's 2-way, 1-way, and checkout check-in. Personal geodatabases for access and file geodatabases can only be used for checkout check-in, or what we call disconnect editing pre-9.2. So only for checkout check-in, Carolyn. Esther from Boise asks, can you change the type of replica that you've created once it's established and being used? No, you really need to consider what type of replication you'll be doing, whether it's 2-way, 1-way, or checkout check-in, at the time that you create the replica. If at a later date you determine, actually, you know what, a 1-way replication isn't what I need 2-way, you would have to recreate a new replica, so there's no way to toggle that. David from Thunder Bay again asks, in a replica, how are conflicts prioritized? Who wins? Well, it's very similar to how conflicts work when you're just reconciling versions, David. You can either choose to deal with the conflicts manually and discover them and walk through the new conflict dialog to see what they are and figure out which version of the conflict you'd like to use, or you can choose to have them automatically handled either in favor of the parent or the child. So the workflow that you would go through is very analogous to reconcile. And the point at which that you would determine which type of scheme you'd like to use for conflict detection would be at the point that you do the synchronization. Let's see here. Tom from Seattle. Do historical versions only do saved edits made to the default version, are those the only time those edits go into the historical version? Yes, that's the case. Edits from other versions, other child versions you may have, don't get saved into the historical archive. Only those made into the default version. Let's see here. Sarah from Toronto asks, two-way seems to be better than one-way replication. Why do we need to use one-way then? The replication teams put a large number of thought into that case and given some very good examples in the desktop help about which type of replication would work better. Just as a quick example, one-way replication really meant to be used when you're trying to push down periodic edits down to another geodatabase. Maybe it's to a contractor or it's to a geodatabase that's being leveraged by, say, ArcGIS server to publish something on the web. Two-way is when you want to pull edits back from that contractor, for instance. So just a quick example of when you'd want to use two-way replication over, say, one-way. But check out the desktop help for that. There's some very good examples of that. Jill?
Great. Thanks, Craig. And at this point, we're all out of time. So I'm going to just finish up by giving you some links to some more information. You know, there are some virtual campus courses that discuss the geodatabase model. There are many instructor-led training courses that will deal with the geodatabase and with non-versioned and versioned editing. In November, we're having another live training seminar about geodatabase replication. And of course, the ArcGIS help and the What's New at ArcGIS 9.2 PDF are great resources. I hope this session has shown you some of the new functionality and enhancements that have been made to the geodatabase. Your comments help us improve our seminars. Please take a moment to complete our survey. Just click the Give Us Feedback link to take the survey. We hope you enjoyed today's seminar. On behalf of ESRI, I'd like to thank you for attending.